All right, hello everybody. This is Mr. Healy talking to you. So today is this last video is going to be a little bit of a discussion about continuity. So most of you should know what the concept of continuity is, and basically we're going to continue with probably the definition of something that you already know. So the way that we're going to define it now, and later on as we talk about some different things as the year moves on, we'll have really the same definition, but just a lot tighter in terms of the calculus definitions and theorems that we're going to talk about as the year moves on. So really, when we talk about continuity, it's hopefully a concept that is familiar to you. So if I have a function, could be any function, could be linear, could be some sort of quadratic, could be anything, could be an exponential. But if you say that it is going to, or some sort of polynomial, which I'm going to draw here, if you say that it is it's a continuous function, that means if I was to redraw this, I would not pick up my pen or pencil. There's no breaks, gaps, or any sort of asymptotic behavior going on. So that's the working definition. That it's not really a definition. It's just a concept that we're going to talk about at the beginning of the year. And like I said, later on we're going to define it much better. So if something is not continuous, like this polynomial function, then it is discontinuous. So if something is discontinuous, there are three ways that something can be discontinuous. So something can be discontinuous. Something can be discontinuous three ways. So this right here is a function of sine x over x. So it looks to be continuous because if I was to trace this along the life of the function, then it looks like a nice smooth curve. I'm not going to have to pick up my pen or pencil. But the thing that you have to notice is that there is going to be some sort of discontinuity because division by zero is undefined. So x cannot be zero here. So what happens with this function, and this is actually a very interesting function because it does have what's called removable discontinuity. So this is an example of removable discontinuity. Okay, so there's actually in this, there's a hole at when x is 0, and there's really nothing else to take its place. So that point has been removed. There are examples of removable discontinuity where there's a hole and then that point is somewhere else in the function, which hopefully you've seen before. So that's one example of discontinuity, and that's removable discontinuity. The other one is called jump discontinuity, and then it could be some parabolic from there. So this is a jump discontinuity because, again, if I look at the life of this function, I do have to pick up my pen, and I have to, in order to trace the function, and I have to jump from here to there. So that is an example of jump discontinuity. And then the last one is going to be a limit of infinity discontinuity. So it's probably something that you would expect. And I'll just draw a function. So, there's a million or an infinite amount of examples that we could have. But say I have some sort of asymptotic behavior going here, and we'll just say that is, oops, I don't know why. We'll just say that's a vertical line x equals 2. So if I have a function that is going like this, and then is going like this. Then obviously I have to pick up my pencil. I can't trace the function without picking up the pencil in order to trace the life of the function. So that would be a limit of infinity. The limit of infinity would be our third type of discontinuity. So that is pretty much it as far as what you need to know for the first day of class. So to sort of wrap it up here, what the videos that we saw, or you should have seen, there was one on Newton versus Leibniz, who invented calculus. So you should have taken some notes on that. Then there was a video on Descartes, and a little bit about him being a philosopher, but also marrying the algebra and the geometry together. And then this last video on continuity and discontinuity. So that's really what we're going to discuss the first day of class. The other thing that you should have also printed out, just to make sure you're familiar with, is the syllabus, and that was part of the first assignment, along with the video of who invented calculus. So that's it. So looking forward to seeing you guys on Tuesday, and then I think we'll again see each other on Wednesday. Okay, see you then.